Okay, you made it to lesson 6.8, your last section of chapter 6, which means you're almost finished your year of calculus. That's kind of exciting. Okay, so today we are going to go through two different techniques in using U substitution and definite integral. So we're going to have those bounds back again, that lower and upper bound, which means you will not be having a plus C. I honestly don't know which method I like better, and it says here it would behoove you to know both. So let's just get started and see if you have a preference. Method 1, this requires you to take out the U, and then before you evaluate the integral, substitute the U right back in. Okay, so here we go. Looking at this problem, you can see clearly that you need to use a U substitution because of this product rule, chain rule type look, okay? So I'm going to let my U equal x squared plus 1. The derivative du dx would equal to x, and then solving for dx, we get du over 2x equals dx, okay? If I'm going too fast, pause the video, make sure you understand that, and then jump back in the game. Okay, so now if I have my 0 to 2, I have my x times u to the third power, and then I have my dx, which is du over 2x. Again, we have to make sure our u substitution worked, and you can see that these x's reduce nicely, and we can pull the 2 through. So we'll have a 1/2 out here from 0 to 2, u to the third du. Now the problem here is this. Our bounds, 0 to 2, are for an x, and we have a u. So right here, it might even be in your best interest to squeeze in an x equals to remind yourself, hey, hold on, I have x's and I have u's, and that's no good. So what we're going to do in method 1 is we're going to first integrate using our u, so u to the 4th over 4, and we will then have to evaluate using our upper and lower bound. Okay, so I'm going to use this notation. Again, that 1/2 has been pulled through, so I won't be applying that to the 1/2. So in method 1, once we have our u, we then say, wait a second, I can't use my x bounds. I need to take that out and replace that with an x problem. So I'm looking at 1/2. I have my x squared plus 1, that's what u is equal to the 4th power, over 4. And now I can sub in to that problem, okay? Okay? If you flip your page, we're going to do method 2 with the same exact problem. It says, this method requires you to take out the u, but then adjust your bounds to make your bounds in terms of u instead of x, okay? So we're going to do the same thing, same u substitution. So let me rewrite that. U equals x squared plus 1. Du dx is 2x, du over 2x equals dx. Over here, and let me actually write x equals 0, x equals 2, okay? So we come through and we say we have x, we have our u to the third, du over 2x. This is all the same from before, which is why I'm going so quickly. I hope you're okay with that. We're going to reduce x's, pull the 1/2 through, okay? And last time, when I went through and I integrated, so u to the 4th over 4, we said, let's take a moment and take this u and turn it into an x. Well, what if I wanted to keep that u and say, well, let's change these? Well, let's just write right here. If u is equal to x squared plus 1, u would be x squared, so x is 2, so 2 squared plus 1 is equal to 5. That's my new upper bound. And u, again, is equal to x squared plus 1, so x is now 0 squared plus 1. So my new lower bound is 1. So I would take this problem and I would just adjust my bounds to be a 1 and a 5 here, because now these are u's, and now I work that way. So here's my 1/2. 5 to the 4th power, again, is going to be that 624.25. Should have known that. Minus my 1/4. And I get 1/2 times 624/4, which again is going to be that 624/8, which gets me 78. Okay? So again, the difference would be, do you want to work with bounds that are x's, or do you want to work with bounds that are u? You can pick either method. Maybe in one case one might seem easier than the other. You just have to make sure that they match up, so be careful. Okay, next example. All right, we have some trig. All right, so let's think about our u sub. Okay, I'm thinking of a u sub that's going to help get rid of something, so I'm going to try u. I'm going to cheat and tell you the one that works. Sine of 2x. Okay, that to me is logical though, because remember we talked about when you take the derivative of this, you're going to get cosine, and when that's in the denominator, that will reduce with this cosine. So that's kind of my logic behind what I picked. Be careful of the chain rule here. Make a note of that. Okay, so derivative, du dx. The derivative of sine is cosine. The derivative of 2x is 2. Okay, so I have du. Let's put this 2 cosine 2x equals dx. Okay, let's see if this worked. So we're going from 0 to pi over 8, sine to the 5th 2x. Our u, actually that was our u, wasn't it? Let's fix that. So this is just going to be u to the 5th power, cosine 2x, and dx is du over 2 cosine 2x. Okay, we have our cosine of 2x reducing. This 2 can be pulled through. Okay, so our substitution worked out nicely. Everything's in terms of u, but don't forget, these are x's. Okay, so now you get to pick which method that you would prefer to do. I guess, let me see what I do later in this. Seems like I changed my bounds later, so I'm just going to do that, that method now. So if I integrate, I'll keep my 1/2. This is u to the 6th over 6. And I have to integrate, we're going to keep this x equals 0, x equals pi over 8 for now. And then let's change that. U is equal to the sine of 2 times x, and x is pi over 8. So u is equal to the sine of pi over 4, and the sine of pi over 4, well that's a 45, 45, 90. The sine is going to be root 2 over 2. Sine is opposite over hypotenuse. Okay, the other guy, subbing in this, u is equal to the sine of 2 times 0, and the sine of 0 is 0. Okay, so my new bounds are 0 and root 2 over 2. So let's rewrite this. We have 1/2 u to the 6th. Why don't we pull this 6 through and make that a 12 over here? Okay. So I'm going to write this as u to the 6th. I'm going to write that as 1/12, pulling that through. And my new bounds are going to be root 2 over 2 and 0. Okay? So I have a 1/12 hanging out here. I have a root 2 over 2 to the 6th power minus 0. Okay, so then right here we get 1/12 times 1/8, and we get 196 for our answer. Okay, next problem. The last one I made a mistake on, so I had to pause it, fix it, and then not let you see that. But this one, we have quite the big problem here. We have to just make sure that we make our u substitution work. Heads up, this is a tricky one, so be careful, and in the end, I will let you use a calculator because the answer turns out to be a decimal, okay? So let's go through. My u sub that I chose was u equals x minus 3. du dx would then be 1, and du is equal to dx. Oops, du is equal to dx. Okay, so it appears that this doesn't work because if I put my 2x minus 5 with my u to the 9th power, du, I still have an x with all of my u's. And again, these are x's here. I really think right with this lesson you should be writing x equals so that you remember these are x's, these are u's. So with this, what I'm going to do is the trick that I showed you before. I need to make this x a u for this all to be a du. So if I come to this piece, what does x equal? X equals u plus 3. Okay? So if x equals u plus 3, then I have, recopy this, 2 times u plus 3, because x is u plus 3, minus 5, u to the 9th du. Okay, did you catch that? So I'm taking my x, subbing it in. So let's simplify this. This is 2u plus 6 minus 5. So that's 2u plus 1. And then a u to the 9th du. Okay, and then there's no such thing as the product rule, so we might as well distribute, and we get 2u to the 10th plus u to the 9th du. So all of this work that we did, our u sub, and then all of this work is just making it so that we can integrate our problem. So hopefully you follow that. If not, maybe replay the video and see if you catch something the second time. Okay, so now we're going to finally integrate our problem. I'll do that over here. So I have 2u to the 11th power over 11 plus u to the 10th over 10. And that has to be evaluated with our bounds. So right now my bounds are in x's. I'm going to turn them to u's. So if x is 5, u would be 2. So I'm going to just rewrite this with my new bounds. If x is 2, u would be negative 1. Okay, so I'm changing my bounds, and then I would use a calculator to fill in my 2 and fill in my negative 1, and in the end your answer should be about 474.845. Okay, so see if you get that. All right, our last example. Let's rewrite this again. All right, so we have from 0 to, that's what, 3 over 4? Let's do 1 over 1 minus x dx, okay? And let's think about what our u sub should be. I'm going to try my denominator. U is equal to 1 minus x. Du dx then would equal negative 1. So du is equal to, let's do the opposite of du is equal to dx. Okay, so continuing with that, again I ran out of memory space. So finishing this up, we're going to be to the wire here. Okay, so I have my 0 to 3/4, 1 over u, and then my dx is going to be du with this negative pulled through. Okay, so the integral of 1 over u, we should all know from our neon sheet, is the natural log of the absolute value of u. I'll stick this negative out here. We'll bracket this off and say we have x equals 0 and x equals 3/4. Okay? So when I go through, I have to change my bounds once I have my values here. So we'll do u equals 1 minus 3/4. So that's going to be u equals 1/4. and u equals 1 minus 0, so u is equal to 1. So my new bounds are going to be 1/4 and 1. So we'll do that right here, and we'll finish this up. So I have so we have the natural log of 1/4 minus the natural log of 1. Okay, so we have the opposite of the natural log of 1/4. And what's the natural log of 1? So let's do this here. Log base e of 1 is question mark. E to the question mark equals 1. See how that has to be a 0? So this value here, guys, is a 0. So the answer to your question is that right there. Okay? So you are officially finished the chapter or learning the new notes. Hopefully your review and your test goes well. I'll talk to you soon. Bye.